Hey guys, Miss Wallace here. I want to talk to you a little bit about force in motion and just kind of go over some of the vocabulary terms. We know that force is the energy that it takes to do work. So when we apply force, work is done. So we know that a force is going to be a push or a pull on an object, and it takes energy to get that object to move. And we know that motion is considered the change in position of an object when that force is applied. So two main things. A force is a push or a pull, pushing in the direction of the applied force, right? That's where the movement would be, or pulling in the direction of the applied force, okay? A push is considered to move away from you, and a pull is considered to move towards you or closer to you. Now, two forces that we experience on a daily basis. Gravity. This is a force that is pulling us to Earth. So I want you to understand this is always pulling. It's always a pulling force. Gravity is not my friend when I trip because it pulls me to the ground. But luckily we do have friction. So friction is going to either slow or potentially stop the motion of an object. And we know the friction is happening right here between the wheels and the ground, maybe even on his little stopper there. If he is moving in this direction here, roller skating that way, friction is working against him in the opposite direction. Now, friction is my friend because that's what helps me walk. So it's every time my foot hits the ground, I push off. There's friction there, which allows me to push off. If we didn't have any friction on the ground, we would just slip and slide all over the place, and that could be really dangerous. So we know that some objects have more friction than others. For example, sandpaper has a lot of friction because it sands down the wood. Carpet has more friction than a tile floor or a wood floor. The tile and the wood are very smooth, so they're going to have less friction. So the more friction, then the more rubbing between the two objects. Okay. We've already talked a little bit about magnetism back when we studied properties of matter, but you have to remember that magnetism is going to be a force. And it's going to either attract or it's going to repel. For attract, you have to think of your opposite poles, okay? Like north and south. That's what it says here. Opposite poles attract and like poles repel. So opposites would be your north and your south. Those are going to attract each other. And what's going to repel would be like north to north or south to south. Okay, those are always going to repel. And you know this, if you've tried to put magnets up to each other, and it's like a force pushing them apart, that's because you've got north to north or south to south. Don't forget that acronym of SYNC, right? We learned that back with properties of matter. Your steel, iron, nickel, and cobalt, those are the four metals that are magnetic. So you would have that attractive force between a magnet and those four metals. Acceleration, this is the ability for an object to gain speed. Okay, so we think of speed as distance traveled over a certain time period, just like your car. You go 55 miles per hour. So speed is considered distance traveled divided by time, right? And that's why we have miles per hour. And that's how we say that. So for example here, as the ball rolls down the hill, it's going to continue to gain speed until it stops, right? Until maybe it gets to the bottom of the hill, friction's going to slow it down, or maybe it hits a wall and it just stops immediately, okay? So if you have any questions about these terms, please make sure you email me or call me and let me know. I can help you understand these a little bit better. You will have a homework packet this week and some other notes pages to review. So make sure that you check out Google Classroom and don't forget to look at STEM Scopes as well. All right, everybody have a great week.